Hey guys, welcome back. We're going to do number 2. This is unit 4, handout 4. It is question number 2 from that same handout. Another RLC series circuit. I've drawn it here. XL is 90. Oops, XC is 90. XL is 70. R is 38. We don't know the voltage. In fact, it's the first thing that it's asking for here. But it does say that the current flowing is 2 amps. So we're going to try this out and let's see how it goes. Okay, so first thing I'm going to see if I can do is figure out the impedance of this circuit. The impedance is going to be the phasor sum of these 3. And so we're going to draw an impedance phasor diagram. I don't know, maybe right over here. Okay, so obviously you should get some scrap paper and do, a better job than I am. But I'm trying to keep it all in this, in this little screen window here. Okay, guys. So here's my circuit. We're going to compare all our phasors to current. The reason we compare it to current is there is only one current in this phasor in this drawing because it's series, and so we're going to compare everything to whatever is constant in the series circuit, which is current. I'm going to start by drawing R. You should always start by drawing the resistor. Doesn't matter what order they appear in the schematic, by the way. Like, these could be all mixed up. It doesn't make any difference. Doesn't change how you do anything. Draw the resistor first every time. It's on the horizontal line, and that's what you should start with. So here's my R. I'm not gonna make it too long here. Excuse me. R is equal to 38 ohms. Okay, we're gonna draw XL. XL is going to continue to be drawn up. Okay, it needs to be drawn up so that the current is shown lagging it or clockwise by 90, but I'm going to move it tip to tail right now. It's 70 ohms, so it's going to go straight up here like that. XL is equal to 70 ohms. That's an L. I'm going to draw XC. It is 90 ohms. Now, XC would sit down here. It would be drawn so that the current is clockwise by 90 because it causes the current to lead by 90, but I'm going to move it tip to tail, so it's going to start here and go down. Now, it is longer than XL, so it's actually going to go straight down here like this. There is XC, and it is equal to 90 ohms. Now, we know that this is going to be X. And X is always the difference between XL and XC, or XC and XL. Just pick the bigger number and subtract the smaller number. Okay, so X is XL minus XC, or X is XC minus XL. Pick the bigger number and subtract the smaller number. So X in this case is going to be XC minus XL, and so it is going to be 90 minus 70, and is equal to 20 ohms. Now, you might be wondering, okay, Ben Andel, this is, goofy now because X should be a negative number, and because it's down here. But it isn't a negative number. It is a positive number. It is a positive number down here. Okay, just like XC, which was drawn right here, it is, 90 ohms drawn as a positive number down here with the current leading it by 90 degrees. And we moved it up here, and it continues to be positive, and there's X. It's 20 ohms. Okay, guys, so don't overthink it. There's no such thing as negative values of ohms. All right, there's only positive values of ohms. You can't say, oh, that resistor there is minus 10 ohms. No, it doesn't work that way. Okay, so it's 20 ohms. It's just sitting below the line here. No big deal. There is Z, guys, and Z is going to be equal to the square root of 38 squared plus 20 squared. Let's try it. Comes to 42.94 ohms. Okay, guys? That's sad. So that means we have actually solved this one right here, 42.94 ohms. That's B. Okay, we're going to do A now, and A is going to be the applied voltage. Now, I know the impedance, and I know the current, So I can use Ohm's law to calculate the voltage. E is going to be equal to I times Z, okay? 2 times 42.94. 85.88 volts. Okay, guys? Now we're going to calculate C here. EXC, well, EXC is equal to I times XC. So it's going to be 2 times 90, 180 volts. D, EXL, it's going to be I times XL. 2 times 70, all right, 140 volts. You know, let's calculate ER just for fun. Let's do it over here. It doesn't ask for it, but we're going to calculate ER should be I times R, okay? So 2 times 38 equals, what is that, 74? 76? 35? 76. I'm going to double check that. 38 times 2. Yeah, 76 volts. Okay, doesn't ask for it, but it could, and so we're calculating it. E, guys, is going to be this triangle right here. All right, so it's going to be 20, opposite, over adjacent, inverse tan. So it's going to be the phase angle, going to be the opposite side, 20 over 38, tan to the negative 1. Okay, so let's figure that out. 20 divided by 38 equals, shift tan equals, comes to 27.76 degrees. All right, now you might say to me now, well, listen, that should be a negative angle. Look where the phasor is here. That should be minus 27, but it is not, because, you know, it's messy. All right, guys, I get it. It's messy. But the reason this isn't negative is because I am no longer, you know, when we were adding and subtracting phasors, guys, I was saying, like, here's a phasor at 300 degrees, here's a phasor at 180 degrees, here's a phasor at 210 degrees. You know, add them up. Tell me where the phasor is. Okay, I'm not asking you where this phasor is. Okay, guys, what I'm asking you is, what is the difference between the voltage and the current? And the difference between the voltage and the current is 27 degrees. Okay, and this angle, right, this answer right here, leading or lagging, will tell me whether the current's leading or lagging. All right, so I don't care where Z is. I want to know how big this difference is. We're looking at the relationship of two phasors to each other, not where they are exactly in the world. All right, and so the relationship is 27 degrees. And here, to figure out the leading or lagging, I'm going to identify the current phasor, which is going to be this horizontal line, and decide whether it is clockwise or counterclockwise from the impedance phasor or voltage phasor, depending on which phasor diagram you're looking at. We're going to draw the voltage phasor diagram for this circuit in a second. But here I can see the current is counterclockwise by 27.76 degrees, which means the current is leading, okay, by 27.76 degrees. All right, guys? So not where is this, not is this leading or lagging, it's is this leading or lagging that. And this is leading that because it is counterclockwise. And one thing you can do to remember the whole counterclockwise clockwise thing is, if it's clockwise, it is lagging. If it is counterclockwise, it is leading. And how am I going to remember that? Less letters, more letters, more letters. Okay, so if you see that the current is counterclockwise, it must be leading. If you see that the current is clockwise, where's my last one that we did here? Hold on. Here, this is the one, this is question number 1. Here I identified the current phasor. I noticed it is clockwise, which means it is lagging. Less letters, less letters. Here I notice that the current is counterclockwise, which means it is leading by 27 degrees. This angle is never negative, guys. It is always going to be positive, which is why I didn't want you to make this minus 20, because if you make this minus 20, the angle does come out negative, and that's not what we're doing. All right, so all these numbers should be positive. This number should be positive. The angle should be positive. Then you can tell me whether the current is leading or lagging. Okay, guys? So while we're here, real quick here, I'm going to draw a voltage phasor diagram for this, you know, not necessary, but fun to do, I guess you could say. So let's draw the 3 voltages that I've got, that I'm dealing with here as a phasor diagram. I'll do it right here, just like this. We're going to compare them to the current. ER, we calculated it right here, 76 volts. Okay. EXL, this one right here, 140 volts. Okay, that's that one right there. EXC, 180 volts. This is going to be called EX, okay? It's the difference between these two. So it'll be the big number minus the small number. Okay, 40 volts. It's a positive number. E total will be the phasor sum of the 3 phasors right there. That is E total. It should be equal to the square root of 76 squared plus 40 squared. 76 squared plus 40 squared equals, square root equals 85.88 volts. Now, notice this, 85.88 volts. 85.88 volts. Okay, the sum of the 3 voltage drops is equal to the voltage rise. Now, if I took a look at this, if I were to try to use this phasor diagram to see if the current's leading or lagging, I would do the exact same thing. I would identify the current phasor, decide whether it is clockwise or counterclockwise from the voltage phasor, and it is counterclockwise, which means the current is leading. Give your homework a try. By the way, number 3 is crazy, so you can try it if you want to, but don't sweat it. It's a goofy one, and it's not going to be like that on the test at all, guys. It's going to be straightforward on the test. So number 3 is a challenge for you to try if you want to. If you can get the right answer, congratulations. If you can't, don't sweat it. Normally I would take that up with the students, but this isn't normal situation. All right, guys. So don't get too wound up about number 3. Or number 8 for that matter, okay? So question 8 on your homework assignment, which is Unit 4, Handout 4. Question 3 and 8, try them. But don't sweat it if they're too weird. And have a good day, guys. Stay safe, be good. Enjoy your courses. Hope you're enjoying the videos. I miss you all. See you later and talk to you soon.